Hi everyone, welcome to ECTC 2026. I'm here today with Shane Ketchum from Sono Tek, and we are going to talk about EMI shielding. Welcome.
Thank you. Like to have me.
Yeah, it's nice to meet you. Is this your first time at CTC?
No, first time in a few years. I was here last time. I was in Orlando. I
Okay,
had colleagues go to the show the past few years.
gotcha. Cool. Well, yeah, I guess we could just start out with a little bit about you and your background, what your company does.
So Sono Tek is an ultrasonic spray coating company. We are specialized in selling robotic equipment for thin film coating. In this industry, we're selling into EMI shielding coatings or photoresist and polyimide other semiconductor material labels.
Okay. So, what exactly is it?
So it shields the chip from uh, outside frequencies. So there's different ways of doing it. There's something called a can. There's different materials you can use, and standard processes that are used now. When they work, they work really well. But as parts become smaller and smaller, or you have parts where you need to only selectively decide where you're going to put the material, that's where our company comes to play. So you can have different topographies that you can code that very poorly, and you can have different types of shapes and different types of 3D types of shapes that may not be coded as randomized.
Gotcha. So, what are some of the main applications of this technology?
So we are, our overall technology is used for anything that is coding. We're big in semiconductor industry, big in medical, yeah, and so we'll code stents with materials. So your body does project the stents. We are a battery advanced energy, kind of all over the place with it.
Wow, it's definitely a wide range of markets. So, what challenges would you say manufacturers are experiencing your day? I know you mentioned things that you smaller. Um, how specifically does this address that?
So as things get smaller and smaller, the tolerances between the parts gets tighter and tighter. And you need coatings. When you have shielding, you need to coat the whole part. If you only shield part of it, then it's not well. So what we're able to do is get to sidewalls of the parts with a very deformed coating, and that helps to shield the parts. Wherever it gets put, it's falling out. So it really is, and it just comes down to, as things are shrinking in the electronics industry, just need different types of technology to get these birds down.
Yeah, and how far down?
So in the EMI side, it's a lot of it's trying to get a freeze. So your thickness, same thickness on top as your side. So it's realistically how tight can you package these parts to get as many of them as possible, so that you can coat as many as possible, so that your output is much higher. When it comes to other things, semiconductor, like photoresist, that is chip level. You might be coating trenches that are 100 by 100 basics. So it's really application dependent.
Gotcha. Yeah, I mean that's crazy. But when it comes to uniformity, how does your product address that?
So because our product is very repeatable, we can deposit one layer process. So you go really thin into 100 layers. So you're able to control how many layers you put down. You're able to control and flow rate. So it's thickness per layer. So if you say you need 10 microns, you can do 10 1 micron coatings, or you can do 10 micron coating. So you have a lot of knobs and buttons to turn.
Gotcha. So for example, one time I run voting, what would be the application area?
I mean, it's throughout, but a lot of it's the EMI side of things. The EMI is usually between 1 to 10 microns, depending on the type of shit, and they need the photoresist side of things as well. They're typically 5 to 10 microns. It's clarifications, but it's nice thing about the technology is it's scary. Someone needs a 200 micron thick coating, we can do that as well. Safe on scope. If someone needs a 500 nanometer thick coating, we could do that as well. It's putting down thinner layers around thicker first.
Gotcha. And then where is Sono Tek based?
We're in New York, halfway between Albany and New York City. We have Frost Dodge River, KFC, and a small sample.
Cool. And then is there anything else that we should know about the movie?
Just not that I think of it. I mean, as you get to the point where you have a really challenging application, that's usually when our volume starts running.
Gotcha. That makes sense. Yeah. I mean, especially when it comes to scaling, it's a major challenge across the entire industry. Yeah. I mean, such a big focus, especially when it was like this. Um, yeah, with AI and with everything, how does this help with that level?
It's typically as we advance the technology, it changes speed.
Yeah.
So it helps just because we have that the controlled speed to put down millions and layers. So it's the same thing over and over again, but as things get smaller, it's kind of more kind of starts and so yeah, we keep up with that. Yeah, exactly. And it's nice and it's easily scalable. We can spray something that's 2 millimeters, but we also spray 0 meter fall. So it's really just scalable and fairly easy to review.
Awesome. Well, that was great. This was super informative. Thank you so much for watching, and thank you so much for joining us today.
Rally.